So just to double check, if we enter this in, the good idea to know how to enter it in, the square root of, and we'll just do 1/16 times 100, and then we'll close the square root, and we get 2.5. So it would take 2.5 seconds, or about, to drop 100 feet, which seems unusual, right? It seems like it's almost instant, or it takes a lot longer to drop 100 feet. But it is in fact, that doesn't in fact take that long. Well, let's suppose that a person takes a very, very long 10-second drop. So if you can imagine dropping in free fall for 10 seconds, theoretically, how high would this drop have to be? So we know that our graph looks kind of like this. And I'm going to scale down my y max a little bit, so I just see this top part here. And so we don't need to really go to 10. Let's just say it's down to about 4 or 3 maybe. Let's see how that looks. So there it is. So this is how long, this is the height itself of the drop, and these are the seconds. So it takes less than 3 seconds to drop 10 feet, which is pretty much something we've just verified. For 100 feet, in fact, or sorry, for 100 feet, it would take less than 3 seconds, 2.5 in fact. So in this case, we want to know, well, how many feet could I drop in order to be suspended in air for 10 seconds? So my function is this, and remember, this function gives ordered pairs of the form h comma t. So I want to know what is the height if the time takes 10 seconds. So I would simply have to put in 10 for t and evaluate this to figure out what h is. Well, the question is, how do I get h out of the square root? Well, first thing I need to do is get rid of the square root so I can operate on what's down here. So how do you get rid of a square root? What's the opposite operation? Well, it's a square. So what I would do is I would square both sides, and remember, the square of a square root, like for example, the square root of 4 is 2, 2 squared is 4. So if I square root something and then I square it again, I'll get exactly what I started with. So that means if I square both sides, I'll have 100 equals 1/16 h. Well, how do I get rid of the 1/16? Another way to think about this is h over 16, and I would have to simply multiply both sides by 16 to get rid of the denominator, and I would get 1600 equals h. So that means a person would have to drop from 1600 feet all the way down to 0 feet from a diving board in order to be suspended in air for 10 seconds. Now we're violating some physics assumptions and some things in physics, like a person's terminal velocity, how the maximum speed at which they'll ever be able to drop. And but theoretically, this would require 1600 feet of distance.